All right, so you guys have sent us some really interesting stuff about how insurance companies traditionally predict what policyholders will do. How likely are they to let their policy lapse,
Hmm.
or how much they'll withdraw from their accounts?
That's right.
And then even more interesting is this brand new method that's being proposed that uses machine learning to get even more accurate predictions.
It is, and this could be really fascinating and a game changer, particularly for products that have guaranteed benefits. Things like variable annuities with a guaranteed lifetime withdrawal benefit. Those can be tricky for insurance companies to manage because the policyholder's choices really directly affect how much the insurer has to pay out.
That's right. And that's where this deep dive gets juicy. We're going to explore why the traditional ways of predicting these behaviors, especially things like lapse rates and withdrawal amounts, might not be cutting it anymore. And then we'll unpack how this new machine learning model is shaking things up.
The traditional approach, which involves something called experience studies, has been the industry standard for a long time. Taking a big pool of policyholders, and you group them based on characteristics like age, gender, and the type of policy they have, and then look at historical data to see, for example, how many people in each group passed away or surrendered their policy.
So they're basically using past trends to try and predict the future.
Exactly.
If historically 5% of people in a certain group let their policy lapse each year,
Yeah.
they just assume that that pattern will continue.
It relies on the law of large numbers. The bigger the group,
Uh-huh.
the more likely the actual experience will match the predicted rate.
Makes sense. But one of the articles that you sent points out a flaw in this approach, specifically when it comes to certain policyholder behaviors. And they use the example of withdrawals from those VA GLWB accounts that we were talking about earlier.
Okay.
They found that people tend to be pretty consistent in their withdrawal habits.
So the research showed that around 90% of people who withdrew the maximum amount from their VA GLWB one year did the same thing the following year. And on the flip side, about 80% of those who withdrew less in the first year stuck to that pattern as well. So this suggests that simply averaging out withdrawal amounts based on a broad group could lead to inaccurate predictions, especially in products where policyholders have options and flexibility.
So if I'm understanding this correctly, if you're only looking at an average withdrawal rate,
Right.
you might underestimate the reserves needed for someone who's consistently pulling out the maximum amount, because those consistent actions aren't reflected in the average.
That's exactly the point the authors of the article were making.
Gotcha.
And they illustrate this with the concept of Jensen's inequality, which basically says that if you apply a function, in this case an average, to a set of values, the result can be skewed if the values aren't evenly distributed.
Interesting.
So imagine you have two identical VA GLWB policies. One policyholder withdraws the maximum allowed amount every year, while the other takes a slightly smaller amount. If you simply use the average withdrawal rate for their group,
Uh-huh.
you would miss the fact that the first policy is rapidly depleting its account value,
Right.
and thus requires higher reserves from the insurance company.
Wow. I see how that seemingly small difference in individual behavior
Right.
could throw off the calculations in a big way.
Exactly.
So is that where machine learning comes in?
That's right.
Does it solve this problem?
This new model, developed by Shaio-Tien and Jack Liu, completely changes the game. Instead of grouping policies together, it analyzes each policy's individual transaction history as a unique data series. It's like giving each policy its own financial fingerprint.
So policy A consistently withdraws the maximum.
Exactly.
Policy B sticks to a fixed dollar amount, so on and so forth.
Precisely. And by recognizing these individual patterns, you can make much more nuanced predictions about future behavior.
All right, I'm hooked. How does this machine learning magic actually work?
Well, the model has two main parts. The first is a recurrent neural network, or RNN. Think of it like a superpowered detective analyzing a trail of clues. It takes a policy's past actions, considers the context in which those actions were taken, things like market conditions or changes in the account value, and creates an embedding.
So it's basically translating all those actions and data points into a code that the computer can understand.
Exactly. This embedding summarizes the policy's past behavior in a way that captures the unique patterns and tendencies.
Gotcha.
Then that code is fed into the second part of the model, a feed-forward neural network, or FFNN. The FFNN takes that behavioral code from the RNN, combines it with other policy information like the policyholder's demographics and specific product features, and then predicts future actions. But here's the really cool part. It's not just predicting one thing at a time. It can predict both withdrawal amounts and the likelihood that the policy will lapse.
Wait, it can predict both of those at the same time?
That's right. That's the power of something called multitask learning.
Oh.
So the model is basically learning about both withdrawals and lapses simultaneously, just like they happen in the real world. This helps the model grasp the relationship between those two behaviors. For example, it might learn that people who withdraw erratically are more likely to lapse,
Makes sense.
while those with steady withdrawal patterns are less likely.
Right.
It's much more dynamic than simply assuming everyone in a certain age group will lapse at a certain rate.
So instead of looking at static data points, this model is actually picking up on the nuances of how people behave and how those behaviors might be connected.
Exactly.
It's learning to read the policyholder's mind.
Right.
I'm dying to know, how well did this model perform in testing? Did it actually deliver on all this promise?
Oh, it absolutely did. When tested on a large data set of VA GLWB policies, it blew the traditional methods out of the water.
Wow.
You're talking a 55.2% lower error rate when predicting withdrawal amounts, and its accuracy in predicting lapses was significantly higher too.
Those are some seriously impressive results. Why is this model so much better at predicting these behaviors? Is it simply that it's looking at the data differently, or is there something more to it?
It comes down to adaptability. Traditional methods rely on static assumptions based on past data. They assume that patterns from the past will continue in the future.
Right.
This new model, on the other hand, is constantly learning and adapting. It takes into account the fact that policyholder behavior can change over time and that the pool of active policies is constantly evolving.
Right.
It's a much more responsive and accurate reflection of the real world.
So it's not just about having more data.
Right.
It's about being able to make sense of that data in a way that reflects the dynamic nature of how people behave.
Exactly.
That makes a lot of sense. One last thing I want to understand before we move on.
Sure.
You mentioned earlier that the model creates these policyholder embeddings.
Right.
The article even talked about how they can be visualized. Can you break that down for me in a way that won't fry my brain? What does it even mean to visualize a policyholder's behavior?
So think of it like a map of policyholder behavior. Each policy's embedding, that unique code we talked about earlier, acts like a set of GPS coordinates on this map.
Gotcha.
So when we plot these embeddings, we see clusters forming. Policies with similar behaviors are grouped together visually.
So you could actually see which behaviors are correlated with a higher risk of lapse.
Exactly.
That's incredible. It's like having a heat map of policyholder risk. You could pinpoint those who are most likely to lapse based on where they fall on this map.
That's a great way to put it.
Wow.
And that's where it gets really interesting from a business perspective. These embeddings can be used for so much more than just predictions.
Now you've got me really intrigued. What else could these embeddings be used for?
Whoa.
Give me some real-world examples.
Imagine an insurance company wanting to tailor their marketing messages. By understanding these behavioral clusters, they could create targeted campaigns for each group, or they could send personalized reminders to those who seem to be forgetting to take their required minimum distributions.
Interesting.
And perhaps most importantly, they could use these insights for proactive in-force management, reaching out to policyholders who show signs of potential lapse risk before they actually surrender their policy. They could offer assistance, adjust the policy terms, or simply provide reassurance to help them stay on track.
Okay.
This type of personalized intervention could drastically reduce lapse rates and lead to happier, more satisfied customers.
This is incredible. It's like insurance that truly caters to individual needs.
Right.
I can already see the dollar signs and efficiency gains dancing in my head.
Right.
But before we get too carried away, let's talk about the practical side of things.
Sure.
How would this model actually be used within an insurance company's existing systems? Would they need to rip everything out and start from scratch?
Not at all. The beauty of this model is that it can be seamlessly integrated into the systems that insurance companies are already using. So think about the actuarial models they use for things like pricing and valuation.
Yeah.
Those models are essentially giant calculators that crunch numbers based on various assumptions about policyholder behavior.
Right. And those assumptions are often based on those simplified group averages
Exactly.
that we were talking about earlier, which we now know can be inaccurate.
Exactly.
Okay.
This new machine learning model essentially replaces those static assumption tables with something much more dynamic and responsive.
So instead of an actuary looking up a generic lapse rate in a table based on a policyholder's age and product type. The model would use that policy's unique embedding to predict a much more personalized lapse probability.
Precisely.
Okay.
It's like upgrading from a generic weather forecast to a hyper-local prediction that takes into account all the specific conditions in your neighborhood.
So how does the integration actually work? What role does the machine learning model play within the larger actuarial system?
So the machine learning model essentially acts within the existing actuarial system.
Okay.
It doesn't need to understand all the intricacies of the actuarial model.
Mm-hmm.
Instead, the actuarial model feeds the machine learning model specific information about each policy at each time step.
Okay.
Things like the current account value, market conditions, policy features, and of course, the policy's past behavior captured in that embedding.
And then based on that information, the model spits back a prediction.
Exactly. It would provide predictions on things like the likelihood of lapse, the expected withdrawal amount, and so on. The actuarial model then takes those predictions and uses them to calculate the necessary reserves, just like it would with those traditional assumption tables.
Right.
The key difference is the level of granularity and accuracy.
So in a way, this actually simplifies things for actuaries.
Right.
No more painstakingly building and updating those giant assumption tables manually.
That's right. This model automates a chunk of the work actuaries currently do.
Wow.
It frees them up to focus on more strategic tasks like validating the model, analyzing the results, and ensuring that the model is working as intended.
Gotcha.
It's a win-win for both the actuaries and the insurance company.
Speaking of validation, I'm sure some listeners are still wondering about the black box aspect of all this.
Yeah.
How do we know this model is actually making reliable predictions and not just spitting out random numbers? So what kinds of checks and balances would be needed to ensure that the model is working as intended?
Actuaries would need to thoroughly understand the model's limitations. They'd need to know what data it was trained on and have clear processes for monitoring its performance over time. They'd need to test it rigorously and validate its predictions against real-world outcomes.
Okay.
It's about having a robust framework for governance and oversight. It's about bringing that same level of rigor and scrutiny to machine learning models that we apply to other critical financial systems.
This is all sounding incredibly probative way.
I think so too. I think the shift from relying on these broad group assumptions to individualized predictions has the potential to fundamentally change how insurance companies operate. It's not just about tweaking a few things here and there. It's really like a whole new way of understanding and managing risk.
So the article mentioned more accurate pricing as the key benefit.
Right.
Can you elaborate on that?
So with more accurate predictions of things like lapse rates and withdrawal behavior, insurers can price their products much more precisely.
So it's not just a win for the insurance companies.
Right.
It could actually benefit consumers as well.
That's right.
That's good to hear. What about the impact on risk management? How could this technology help insurance companies better manage the risks they face?
Well, with the deeper understanding of individual policyholder behavior, insurance companies can become much more proactive in how they manage risk. So, for example, they could identify policyholders who are showing early warning signs of lapse risk and intervene before they actually surrender their policy.
What kind of interventions could they offer?
Well, it could be something as simple as reaching out to the policyholder and offering assistance, maybe helping them understand their policy options better. Or perhaps adjusting the policy terms to better suit their current needs.
Okay.
It's all about providing support and resources to help people keep their policies in force.
So it's not just about crunching numbers and making predictions. It's about using those predictions to actually improve the customer experience.
Exactly.
That's a really interesting perspective.
It's about moving away from that one-size-fits-all approach and offering policies that are truly tailored to individual circumstances and risk profiles.
That sounds like a really positive development. It seems like there's a lot of potential for this technology to make the insurance industry more efficient, more accurate, and ultimately more customer-centric.
I agree.
So as we wrap up this episode, what's one key takeaway you'd like our listeners to ponder?
I think the most important takeaway is this. Machine learning in insurance isn't just some futuristic concept. It's happening right now.
It is.
The tools and techniques are available, and the potential benefits are significant. But with that power comes a responsibility to use it wisely and ethically.
That's a great note to end on.